All right, the last thing that we need to do in this chapter is conversions. Because a lot of what we do in chemistry is not plug stuff into formulas, but in fact just convert from one set of units to another. And we have a process that we need to use doing this called dimensional analysis. And we're going to pretty much do every conversion problem the same way. So let's work at it and see if we can get good at it. So, converting units. Most of them really do involve, problems in chemistry really do involve just taking one unit of measurement and putting it into another one. For example, you may want to convert between pounds and kilograms or centimeters and millimeters. And what we're going to do is we're going to get and go from one to another using conversion factors. Conversion factors are just identities. For example, 1 inch is equal to 2.54 centimeters. And as soon as we have an identity, we can take and make a ratio out of it. So first of all, there are exactly 2.5 centimeters in 1 inch. And we'd put 3 lines there if we'd like to make sure we know it's exact. If we do this, we can divide one side by 1 inch or the other side by 2.54 and get ourselves 2 conversion factors. Now we do this because we don't know which one we're going to need. We don't know if we're going to need inches in the numerator or centimeters in the numerator. So we're going to start out with an identity, a relationship between two units, and we're going to take and generate conversion factors out of them, which is taking an equality and turning it into a ratio. All right, conversion factors. Now we frequently get these from word problems. So a motorcycle was traveling at a speed of 85 kilometers per hour. First of all, this per is the same here as this slash, which is the same as the line between the numerator and the denominator. And note, we are never ever going to use slashes. So I'm going to call these, in our problems, we're always going to use a clean line between the numerator and the denominator. So if we have 85 kilometers per hour, note the per hour, the one that is in this hour is assumed, and we're just going to assume that it is there. The sig figs are contained in the numerator. So if we have 85 kilometers per hour, we can either do 85 kilometers per hour or an hour, and we can put the 1 there if it makes us happy, per kilometer. The units or the sig figs come from the 85. If 1 tablet of vitamin C contains 500 milligrams, then we are going to have 500 milligrams of vitamin C per tablet. And this 1 tablet, and we can put the 1 in there or we can leave it off. Again, the 1 is optional, and the sig figs are here in the 500. So what do we do? So the first thing we tend to be given a word problem, and we need to write down what we know and that what unit we are trying to get to. We're going to find the conversion factors to get there. And at this point, you may just have to Google them. On the test, obviously, we would give them to you. The only things I expect you to have memorized are those metric prefixes. And what we're going to do is realize that we're going to take and cross off our units from the numerator to the denominator so they do not appear in the final answer. So for example, if I want to convert 2.54 quarts to a liter, I can get myself some information. I can look up and realize there's 0.946 liters in 1 quart. I equally look up and find that there is 1.057 quart in a liter. It doesn't make a scrap of difference which one you use. They're the same thing. I'm going to use this one for absolutely no good reason. This is going to be an equality, so I can turn this into a conversion factor. And I can write 0.946 liters per quart, or a quart for every 0.946 liters. Now, the one I'm going to use depends on what I have. So we're going to start out with our piece of given information. Our given is our fixed measured value, it won't be a conversion. And what we're going to do is we're going to take and do dimensional analysis, which means we're going to look at our conversion. And we know we need the liters to quarts conversion because these are the units that we have. If we have a quart in our numerator, we're going to put quart in the denominator because we can divide units the same way we do numbers. So for example, 2 over 2 is 1, or a quart over a quart equally divides through as 1. So if I take and divide out my quarts, I'm going to put my liters on the top, and that is 0.946 liters. My quarts have divided out, and I'm going to get a value here of 2.365 liters. I'm going to check my sig figs too. So I need 2 here, and I'm going to get 2.4 liters. So start with what you know. Get a conversion factor that's going to allow you to get out of the units you have into the units you need. Cross off the units that you start with and stop when you get the units that you need. Might be multiple steps. So the ski pole is 36 inches in length. How long is it in centimeters? Well, we know we need to go from inches into centimeters. So we look up conversion for that, and we find there are 2.54 centimeters exactly in 1 inch. And if we do this, we're going to start out with 36 inches. We know we have to put inches in the denominator so we can cross off that unit, which means we put the 2.54 centimeters in the numerator. And when we multiply that through, we are going to get to 2 sig figs, 91 centimeters. If our pace on a treadmill is 65 meters per minute, 65 meters per minute, or 1 minute for every 65 meters, and I want to know how long it's going to take me in minutes to walk a distance of 7,500 feet. I know I'm going to have to go from feet into something that I can use here, which is going to be meters. So I've got to go from feet into meters and then use my meters into minutes to get units of minutes at the end. Well, I can look this up and discover that there are 0.305 meters per foot. This is going to be another conversion. So I have 2 conversions and I have a measurement. My measurement is my fixed value, meaning it only has, in this case, a numerator, 7,200 feet. It is not a ratio, meters per minute or feet per meter. So I'm going to start out with it. So I'm going to put feet in the numerator. I'm going to get my conversion, which contains feet, and put 0.305 meters here. I'm going to cross off feet, and now I have units of meters. My next one here, I'm going to put meters down at the bottom and put minutes up at the top. I'm going to put 65 meters per 1 minute, and I'm going to cross off meters. And so my feet have divided off or crossed off, and my meters have crossed off. I'm going to multiply through. My answer is going to be to 2 sig figs from the 7,500, and I'm going to get 35 minutes. Start off with your measured value that is not a conversion, and then use your conversions to get into the units that you want. All right, so if someone loses 0.3 pints of blood, how many milliliters of blood would that be? Well, we know some things. We're told that there's 2 pints per quart. We also know that there are 0.946 liters per quart from working with that problem earlier. And we also know about mils. So we need to always remember our metric prefixes. We know that there are 1,000 milliliters per liter. So now we have 3 conversions that we need. We know we need these 3 because we've got mils at the end. This conversion is in liters per quart. And we know that we are going to go from pints to quarts because we've been given that hint. So we're going to start at 0.3 pints and go from there. We know there's 1 quart for every 2 pints. Pints cross off. We know there's 0.946 liters per quart, and the quarts cross. And then we know that there are 1,000 milliliters per liter, and the liters cancel, and you're going to get a volume, the 3 sig figs of 142 milliliters. Note this value is exact, as is this one. All metric prefixes are exact, and this was a definition. All right, let's do a couple more. If we have Usain Bolt running 100 meters in 9.58 seconds, let's convert his speed into miles per hour. So we're going to have to go from meters into miles, and we're going to have to go from seconds into hours, so we're going to need some conversions. There are 3,600 seconds in 1 hour. And then from meters to miles, let's see what we know. Well, we know, we can look up that there's 1.609 kilometers in 1 mile. And we know that there are 1,000 meters in a kilometer. This one we know from our metric prefixes, and the rest of them would be given on an exam. So let's work this one out. You can do this multiple ways. I'm going to do it in one big step. 1,000 meters for every 9.58 seconds. I'm going to do it in this order because I know I have to have distance on top and speed on the bottom. 3,600 seconds per hour is going to get me out of seconds into hours. I need meters on the bottom. I know that there are 1,000 meters per kilometer, and so that gets me out of meters. And then I'm going to go into miles. I know there's 1 mile for every 1.609 kilometers. Kilometers divides out, and I will get an answer in miles per hour. When I do the math, and the math on this, by the way, would be 100 divided by 9.56 times 3,600. You can do this in any order. Divided by 1,000 divided by 1.609 is going to give us 23.4 miles per hour. All right, so I have a room that's 11 by 11 inches, or 111 by 96 inches. I want to know how many square feet that is. There's a couple of ways to do this. I can either take 111 inches and realize there's 1 foot for every 12 inches and get feet. And I'm going to take 96 inches and realize that there are 1 foot for every 12 inches and get feet. Or I can take 111 inches and multiply by 96 inches, get a total of 10656 inches squared. Realize that I've got to convert both of these inches into feet. So I'm going to take my feet for 12 inches to get square feet here. I have to do this, both of these measurements, which means I have to square that. This is going to give me feet squared and divide by 12 inches squared. Note, I've got to take and divide this by 12 squared as well as inches squared. And that is going to give me a total of 74 square feet. All right, I'm going to need to get a little bit extra. So let's get 75 square feet rather than 74, just so we don't screw up. We want to know what this would cost. Well, if I start out with 75 square feet, and I am told that each tile costs $12.99 per 2 square feet, I can do my math here and get a total of 487. If I round to 2 sig figs, $490.